Hello and welcome to Amulya's Academy YouTube channel. In this algorithm video series, next let's talk about jump search algorithm. Jump search is a searching algorithm designed for a sorted list of items that can be considered a modified version of linear search, specifically tailored to improve efficiency. Instead of checking elements one by one like in linear search, jump search skips a fixed number of elements at each step. Jump search compares the target value with the last element of each block. This allows it to quickly determine which block might contain target element. Once the algorithm identifies a potential block where the target element could reside, a linear search is performed only within that identified block. Okay, next let's talk about jump search algorithm in detail, step by step. So here input is list of numbers, sorted list of numbers. Then a target element. First step, decide the jump size by taking the square root of the list size. So here block size is nothing but square root of the list size. Start at the first element of the list. Jump ahead by the jump size and compare the target with the last element of the current block. If the target is greater, move to the next block and repeat step 3 until the last element of the block is greater than or equal to the target or the end of the list is reached. After finding the block, perform a linear search within that block from the start to end. If the target is found, return its position, otherwise return not found or -1. Alright, next let's take an example. Here we have list of numbers, sorted list of numbers. Numbers are in the ascending order. Then here let's take target as 34 and here first let's calculate the jump size or block size. There are 10 elements here. You can take jump size or you can take a variable step is equal to square root of 10. What is square root of 10? 3 point something. So we'll take only integer part 3. So here step or jump size is 3 for this example. So here each block contains 3 elements. We can write it like this. Now what we need to do is we need to compare the target element with the last element of each block. Let's start from the first block. So last element of the first block is 5. Compare it with the target element. Here target is greater than the last element. 34 is greater than 5. So that means the target element is not present in this block because numbers are sorted here in the ascending order. So we need to check for the next block. In the next block, the last element is 56. Compare 34 and 56. 34, that is target, is less than 56 here. The last element is 56, which is greater than 34, that is the target element. If our target element is present, then it is present in this block. So what we need to do is now we need to apply linear search on this block. Elements are 22, 34, 56. Apply linear search. Compare the target element with the first element of the block. 34 is equal to 22? No. Then check for the next element. 34 is equal to 34? Yes. So here target is found, you can return its index. Next, if I take another example, let's take our target element as 123. Jump size or step is 3. Compare the target element with the last element of the block, first block. No, here target is greater than the last element of the block. So go to the next block, compare the last element of the second block. So here 56 and our target is 123. Your target is greater, so check in the next block. Compare the last element. 123 is greater than 123. No, here target is not greater than the last value of this block. We need to apply linear search on this block. Compare the first element of this block. 78 is equal to 123. No. Then move to the next element. 90 is equal to 123. No. 123 is equal to 123. Yes. Target is found. Next, let's take another example. Here we have 20 elements, right, in the ascending order. So here jump size is, or we can say block size also, square root of 20. So we'll get 4 point something. Block size is 4. Each block will contain 4 elements like this. If I want to find 21, what I can do? Compare the last element with the target element. Here target element is greater than the last element of the first block. So move to the next block. Target element is greater. Move to the next block. Target element is greater. Move to the next block. Target element is greater. move to the next block. Target element is greater, move to the next block. So we don't have any other elements to check here. So target is not present in this given list of numbers. Next, let's take another example for not found scenario. Let's take target as 21. So here length of the list is 10. So square root of 10. So we'll get step or jump size or block size as 3. 3 elements are present in each block except the last block, because here length is not a perfect square. So because of that, last block can contain one or fewer elements than the block size. Then here first last element of the first block, that is 5, and target element is 21. Target is greater, so check for the next block, 56 and 21. So here target element is smaller than the last value of the block. So 56 is greater than 21. So we need to search 21 in this block. So apply linear search. 22 is equal to 21. No. Then check for 34 is equal to 21. No. Check for the next element, 56 equal to 21. No. Then we don't have any other elements to check here. So 21 is not present in this list of numbers. So we can write the message target is not found. Okay, so this is how jump search algorithm works. First, we need to determine the jump size, or we can say block size, or we can call it as step. To calculate that, we'll use square root of list size. So we'll divide the numbers to different blocks. Then we'll compare the target element with the last element of the each block. If target element is greater, then search for the target in the next block. If target is equal to or less than the last element, then search the target in that current block. And when we identify a potential block where the target element could reside, we'll apply linear search algorithm on that. We'll compare the element one by one in the sequential order. And jump search algorithm works on sorted list of numbers. So this is about jump search algorithm. In the next tutorial, we'll write the program. So that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.